Controlling local slopes on a surface can be important for things like a gasket in order for it to seal, or perhaps a bearing rolling over the surface to not accelerate or cause noise. And that is the reasoning behind the RDT or WDT or PDT kind of parameter, is to capture those areas of steep slope. In this particular case, let's look at this surface in terms of the slope at every point along the way. At this particular point, the slope or the tangency would look like this. At this particular point, the tangency is rather horizontal. However, as we get into this valley, this region right here, our slope becomes steeper. This steeper slope could cause a problem in terms of the function of this surface. Like I said, perhaps a gasket can't seal if the surface is too steep at that point. The DT parameter helps us describe this. D means delta. It's the amount of change for a given amount of shift along the x-axis. In this case, DT, delta total, is actually referring to the maximum slope, the maximum gradient. Gradient's another word for slope or delta, and the maximum gradient is the steepest slope. Now this is the steepest slope regardless of direction. That's the absolute word. The absolute means the absolute value, it's up or down, and we can capture the steepest slope in our surface. Now, roughness and primary are going to be dominated by the short features. The short, fuzzy features along the way will cause the steepest slopes to occur. So in many cases, like gaskets or bearings, what we're more interested in is the slopes in the waviness domain. A waviness slope can cause noise in a bearing. So the WDT parameter might be a useful way for catching a dip in the surface. WDT, waviness delta total, would capture this steep slope in the red profile, which could lead to noise in a bearing or leakage in a seal.